think we'll get started. Looks like it's 2:45. So I'm here today to talk a little bit about lift and shift effort that my team, a number of other teams within Granular, worked on about a year ago now. And so walk through a few of the details and also start to get into a little bit of where we've gone since then, now that we've had the ability to start to re-architect and such. So we'll cover a little bit of the background and introduction to the work, some of the challenges and the enablers to those challenges, and then really get more into the migration, and then really it's how we've gone cloud native since. So with that, a little bit about me. I know a few of you in the room. I work at Granular, a local software company focused on agricultural software. So the team is really primarily based between San Francisco and Johnston, Iowa. And so we are kind of a spun out organization from DuPont Pioneer. So I'll get into more details on that in a minute. A little bit about me. You can see I've worked at DuPont Pioneer for about 10 years and then ended up in the Granular organization in the past 6 months as we acquired Granular. So another shout out I need to do is to the team that did a lot of the lift and shift work. There's a couple of them in the room here right now, but it's really important to acknowledge that they did a ton of this work as well. So it's a huge team effort. So a little context, just to level set on who we are as Granular. Many of you know Pioneer, I'm sure, in the Des Moines area. But really, Dow and DuPont are coming together. They formed a new company called Corteva. Pioneer's part of that, but then we are a company called Granular. So Granular is a software company that was acquired in 2017. And I came from the Encirca Group, and most of what we'll talk about today was actually done by the Encirca Group based out of Johnston. But we are now part of the Granular organization. And so a little more, like I mentioned, so about 500 employees, 4 locations. We started really the primary software development for our products in 2013. And at that time, we really embraced the DevOps, and we started to look at cloud first. It took us a while to get there. We did have a pretty good split between on-premise data centers and the cloud for a number of those years. But we'll really get into the details here of how we got to the cloud. So, like I said, software for agriculture. So focus on business around agriculture and farming, agronomy, and land. And today it's really about how do you take the approach to get to kind of cloud-first architecture, and especially when you're already in an on-premise data center and you might have a lot of legacy that comes along with that. And so really, what does it take to get to a cloud provider? I'll focus on AWS. A lot of these same ideas will apply to just about any cloud provider out there. So lift and shift, I'm assuming many people have heard the term, but really it's just a strategy for how do you get to the cloud and move your existing software out to the cloud. And so really a few of our drivers really is, re-architecting is going to be expensive to do that in place. Risk mitigation is another big part of that. And so obviously we had some scaling things that we need to do very specifically, so that was a big part of it. And then quick wins, and I think everybody would say that they were interested in quick wins regardless of your software. And then really looking at how do you improve high availability, disaster recovery. So this is a huge one, specifically for us, but really for just about anybody that's going down this road. And then lastly, the speed of innovation. We knew as a software company we were going to be pushed hard to deliver quickly, and so really being able to move fast was a huge driver. And additionally, very specific to us, it was really, we had reduced budgets within our IT organization. That's a big impact. We had siloed organizations. We still do across the board within even Granular today, and we're working on bringing those silos together into a cohesive organization. And then really focusing on automation. I said we need to go fast, so we need to be able to automate everything. And really getting to more of an autonomous state. So we want to be able to function independently. We knew that business was going to need to function completely independently of the parent organization. And so getting to a state where we can actually do that and be independent and live on our own. And then lastly, it's really the global presence. We knew we were going to have to be in many, many countries over the next few years. And some of those countries, even a company the size of DuPont, doesn't really have a big infrastructure set up in some of the countries we need to be in. So we need to be able to handle that on our own. So what I'll do next is kind of walk through maybe some of the challenges that we experienced, and these aren't things that I'd say are unique. These are things that I think apply to just about everybody that's going down this road. And really first thing to think about is when taking on some of this work, what it takes. And this is really a big part of it, is really thinking through what are all the things today that you are getting for free in certain cases because you're part of a large organization. And in our case, we had to go independent. But there's a lot you have to account for. We think about platforms, right? So who manages your Windows, Linux, VMs? Who manages your databases, even appliances within a data center? The larger infrastructure components, so like I said, web applications, the app servers, the database servers, load balancers, all the way down to the network. There's a whole bunch of stuff that typically comes for free in a data center. And these are things that we knew we were going to have to take on ourselves. And there's also services that tend to just be forgotten, right? So DNS, it's a really easy one to forget about. That's you now have to worry about yourself. And all the way down to monitoring security, things like that. But really, some of the really tough things that we discovered, and I don't think, again, that's not unique, so appliances. So these are typically proprietary hardware devices, right? So think about a web application firewall, or even think about an API gateway. There's specific hardware actually installed in your data center that helps manage a lot of that. And so those are things that are unique. They're going to be hard to figure out how to account for in the cloud. Another piece, don't forget Apple, right? So how many of you have CI/CD pipelines that are using Apple products? Nobody? What? Come on. All right, so let's say you have an actual continuous integration pipeline for iOS. That's going to be a huge pain to have to figure out. And as many of you probably know, Mac OS isn't something you can just go run in the cloud very easily or legally in certain cases. So that's another thing you're going to have to account for. And this one I really call out because they're forgotten very quickly. Monitoring, security, compliance. Lots of times these are services that just happen for you in your on-premise data center and aren't things you're necessarily thinking about day to day. And so these are things now, in our case, we had to worry about them. Anytime you're going to move to a whole new hosting platform, you're going to have to worry about these. And these are really sticky areas that aren't necessarily fun to get involved with. So getting more into the challenges. So people and skills, right? So developing cloud engineering skills isn't something that just happens overnight. There's not a lot of people. I mean, hopefully, I guess in this room there is, but there's not a lot of people out in the market with cloud engineering skills. And so that really was a big thing for us. So we had a very limited knowledge of AWS when we got started. And so building those skills was absolutely critical to us being successful. So what we ended up doing in this case really is looking at how can we hire these skills very early on? How can we bring in some experts very early on? And another big piece of that was really identifying evangelists. So nobody was really named an evangelist in our case, but there were some people that clearly would step up and wanted to be more involved with the effort. And so giving them the ability to do that was extremely important. And then in our case, leveraging AWS solutions architects that come from AWS, Azure, or Google, or others have the same thing. But this is also a critical piece. So being able to leverage the knowledge that's out there, it's kind of given away for free to a degree. So that was extremely important in our case, and is something I think could really benefit most people that go down this road. So another fun one, in our situation, maybe we're a little bit unique here, getting administrative connectivity out of your existing data center, because I'm guessing most people, and I'm looking at Jason, the security guy in the room here, probably don't want people on their network just tunneling SSH traffic out. But the reality is, we had to do that. So that's a huge challenge. You're going to have this for probably any port you want to get out of your internal network out to the cloud on. And so in our case, it was a big challenge. Trying to get that connectivity and doing that in a secure way was actually something we needed to accomplish. And so we really built out our environment. Instead of standing up a dedicated VPN, we went the route of using bash and host as SSH gateways. And we would route all of our traffic over there and be able to actually secure that tunnel. And so this is actually a recommended pattern from AWS. There's a couple links at the bottom. But we really established a hub and spoke model within our cloud networking. So our VPCs really follow a hub and spoke model. So monitoring and alerting. So I mentioned this is one of the sticky ones that kind of just happens for you in a lot of cases in your on-premise data center. This is now something that you have to account for. So I'm sure many of you have used Nagios or very familiar with Nagios. We were using Nagios heavily, but that wasn't something we managed. That was a totally separate operations group that managed that. And so trying to self-support that is something we had to pick up. What we decided to do is really heavily invest in a SaaS solution for this, so actually using a separate third party for our monitoring. In our case, we're using Sumo Logic today. We've been through a couple different iterations with different providers. And some of this comes with AWS, for example, or your cloud provider. And so CloudWatch is just one example of that. But this was a case where we knew we had to do this early on. This is actually a piece of it that really led to the success of our lift and shift. So source control and builds. So how many people host their source control out in the cloud? There's a few. All right. Yeah, so I'm guessing many people have probably heard some pushback on even going down that road, mainly for security reasons, compliance reasons and such. This was something we battled as well. We had to overcome this. And we actually took the approach of, instead of going and using what the cool kids do, right? Go use GitHub, just throw your code out there and hope for the best. We decided we were going to run GitLab and run it ourselves, but we're going to do that out in AWS. That gave us all the security controls that we needed and we desired. And so that was really important to us really moving forward. And so, like I said, cloud-hosted source control, right? So that's really important. Also being able to build a scalable build system was extremely important in our case. We had varied degrees of success on-prem over the years, but part of the problem was it just wouldn't scale. We had a single host here or a single host there that was running Jenkins or some other CI tool. That wasn't enough. We needed the ability to spin up new hosts and slaves on demand. So that's what we were able to do. Makes it completely much easier doing this out in the cloud, obviously. And so that's exactly what we did. So application authentication. We were using SAML 2.0 for our application authentication. While that seemed like it worked okay, the user experience, one, was a little messy. We were specifically using ADFS for most of that. The other problem that comes with that is the portability. So if you're going to Azure, it's not as big of a problem. I'll be the first to acknowledge that. Doing this with AWS is an interesting challenge. You certainly can, but it presents some problems as well. So we knew early on what we need to do is migrate to a different identity provider for application identities. So we actually took on the effort very early to move to Amazon Cognito. And so what this gave us now was actual OpenID Connect and then authentication with JWT for all of our actual web services. And so that was actually a big piece of it. But that really kind of plays into some of the API gateway. So how many of you have API gateways deployed today? All right, good. So we, over the years, had an API gateway that was, like I said earlier, an appliance. This was something that's extremely proprietary. This was hardware-based, obviously fairly configurable, but again, it was very proprietary. And so this was something we knew we were going to have to solve for, and we actually looked at it as an opportunity for us. We actually preferred the way that our API gateway appliance did some of the work because it would actually help us with some of the complex routing we need to do. It also served as kind of a security gateway, so really helping with the authentication into our environments. And so it was something we knew we wanted to continue with, but we didn't want to have to rely on some third-party proprietary technology. So we ended up building our own. We did this, it's really based on Apache, and it was actually a very small project to go build our own to do this. What this actually gave us was a couple nice things. Number one, we could actually deploy it as infrastructure as code, and we could actually configure it in an automated fashion, which previously we hadn't been able to. And secondly, it actually would allow us to use SAML plus use Amazon Cognito JWTs. And so Amazon Cognito JWTs, if anybody's ever worked with them, they're actually a little bit unique. There's some special things you have to do. And so we actually had to go modify the plugin that actually handles JWT authentication. But that's a case where we were able to quickly adapt because we weren't constrained by a third party. So that was really important for us. I have a link at the bottom here for that additional module. SQL Server clustering. So in our world, I know some of you are probably aware of this, we have a massive, massive SQL Server set up for our production environment. And it's grown significantly over the years. And so one of the things that we knew we had to do is figure out how we're going to move that and make it work on AWS. And we couldn't use RDS, so database as a service. So we're going to have to manage all the VMs ourselves and manage things like failover, and it got a little crazy, to say the least. So there was other things such as IOPS. Our IOPS requirements were a bit significant. IOPS restrictions were part of it. Another part why we couldn't use RDS was just generally the size. We were too big of a size of database. There are also significant features that we use that aren't part of RDS, even RDS Enterprise for SQL Server. So we knew we were going to have to run it ourselves, and we're going to have to figure that out, and we're going to have to learn quickly. Luckily, we were able to hire a DBA that had experience with SQL Server to come onto the team, so that helped us significantly. But there were plenty of challenges we knew weren't necessarily generally solved problems that we were going to have to solve on our own. So we went with SQL Server high availability groups. That worked fairly well, but there are some interesting problems. So we are very much a mixed shop when it comes to programming languages and technologies. So we leverage, of course, .NET, but we also are very heavily invested in things such as Python and other languages. And so one of the problems there is the drivers don't just handle the failover. So we actually had to address that. So HA proxy was actually our solution for that. So we were able to throw HA proxy in front of our SQL Server cluster to handle that routing and quickly route the TCP traffic in a failover and actually prevent us from having downtime. And then the IOPS was another huge issue. So we had to actually use RAID array underneath the actual server on EBS volumes on each of the hosts. And so that, again, it has worked very well. But there's plenty of things that on AWS aren't standard that we're doing that I don't think very many people have had to actually face if you're able to leverage some of the tooling out of the box. So testing of the deployment. So this is where things get interesting. So be able to actually test this while maintaining a production environment on-premise became a really good challenge to try to figure out. So what we didn't want to do is just wait until the day we go live and hope for the best. Clearly we need to do some pretty robust testing up front. So what we ended up doing is really what I would say is kind of the same concept as dog fooding. And so we would roll through each environment very slowly and basically rehearse. So rehearse like it's the night of the cutover. This helped us significantly. We were able to see very quickly in each environment if there were issues and be able to roll back easily. So I'll walk through a little bit of that here in a minute of exactly how we went about doing that and how we kind of piecemeal that in. So think of it like this. So right, you have your customers using your software, going through your corporate data center. What we did was actually first look at, well, what's the easiest thing to just make happen? So cut DNS. That's pretty dang easy. We can make that happen. We can be running in production right away with DNS moved over to AWS Route 53. So we had that happen very early on in the project before we even went live with much else in production. And then I had mentioned, we decided early on as well, we knew we needed to change our application authentication. So we decided way before we even did the cutover, let's just start using Cognito, but still have our application on premise. So again, just piecemealing things in to get us closer to the state that we want to be in. And then it really came time to figure out, builds, source control, the whole CI/CD pipeline. And that's when we really started to take on a lot of the work is let's move over Jenkins to AWS, but deploy back into the on-premise data center. Same goes with source control. Let's move the source control out. So with that, once we were in that state, we were able to start testing really basic things, such as, just move your static content out there. Let's make sure that that's functional. Make sure DNS is resolving properly. And so we could actually get our testers starting to get a little bit of an experience of what the application will be like. But that really didn't get us everything we needed, right? We still had a ton of APIs, had a ton of databases. And so we were able to start to just piecemeal this in. Looks like a lot of infrastructure, right? So that was kind of the big bang that we had to do through each environment was really drop these pieces in. And so that includes, all of our APIs, our gateways, databases, some of our event processing engines. And then we were able to start to really replicate our SQL Server cluster and start to replicate data. So incrementally shipping data up just to keep in sync. The nice thing about that, though, was once we started to get into that state, and in each environment we were able to do this. You would have basically the cloud environment up to date with what's on-premise, and then you just cut ties. And at that point, you can start to cut people over. And so this is really how we kind of stepped through it piece by piece, and this is over roughly about a 6-month period. I will caveat that with what we really ended up doing is focusing on that big bang, the last piece of that, doing that all at once. And so each environment we did progress over the 6 months, but then that last piece, there was an evening where we had to actually take some downtime. So that ended up being roughly less than 15 minutes of downtime. There were some interesting challenges, and some impacts to customers, and so we can talk about those a little bit too. So one of them is we had increased error rates, we had degraded performance. The monitoring that we had put in place actually was a savior in this case. So the degraded performance was actually a total miss by several of us on the team. You can kind of see the comment there, and that's kind of how I felt, that guy up there. The 100 gigs versus 4 terabytes on one of our databases. And this is a database that really isn't looked at heavily. It's not something that's really read heavy, but the additional storage and IOPS requirements actually had a huge impact. And so we didn't catch that in our non-production environments. So that was a huge miss that caused us a little bit of shakiness very early after the cutover. But the real positive thing is like all issues were resolved throughout the evening. And so we were able to get to a state where we felt very good about it. And so I talked about the monitoring. This is what we were able to do. This had had a significant role in helping us identify where we were and what the issues were. And so we can actually take a look at this and start to see right away, performance degradation. We had a major performance issue, but we knew the minute we had that fixed, things went back to normal. So June 11th, the evening of June 11th is exactly when we did the cutover. And then additionally, a couple days after that Monday after, somebody might have made a mistake in a deploy job. And so we were able to identify that very quickly and resolve it as well. So the monitoring was a savior, and it's actually better than what we ever had before. The actual response time, this also showed us some really interesting things. So first of all, on the far left there, you can see early in the day we shut down some of the non-essential processing. So suddenly you see response time improving slightly. And then you can see when we did the cutover of the traffic, we dipped for a second, and then all of a sudden performance went kind of out of control. We saw some really big slowdowns in the application. But once we got that resolved, like I said, we got that resolved that evening, you can see now the average performance afterwards is actually quite a bit faster than what we had when we were on-prem. And so we actually met some of the things that we thought were like stretch objectives of actually improving performance. We were able to do that right out of the gate, and that's various reasons. Some of it is the configuration we had set up out in the cloud was a little bit better than what we had on premise, but more so it's networking related. The hops to get to the actual regions is much quicker than coming back to Johnston. So that was a huge win for us. The real win, though, is customers, right? So I'm not going to read this. You guys can read it. This is from one of our users. Had to remove a little bit of the colorful language that was in here, but happy customers means you probably did the right thing. So we felt really good after seeing this, but it's one of those things where starting to get the feedback shows that things were a success. And obviously, as we continue to talk to users, we continue to hear of the big wins that we have. So a little bit on going cloud native. So first off, I think the important point here is taking your hosting platform and your software that might not be so good sometimes, and just moving that to the cloud isn't going to really equate to the cloud and rainbows and unicorns. That's not what happens. So there's a huge need, especially for us after we got out to the cloud, to start to think about how do we re-architect the system. So what we've done since, we really started to focus on cloud native architecture. We really invested heavily in serverless. So things like Amazon Cognito and API Gateway and Lambda and RDS and Elasticache. We've really invested heavily there. But the two pieces that we've invested heavily in, even more I would say, is really the continuous delivery pattern as well as infrastructure as code. This has been enabled by us now being in the cloud. This is something, if we wanted to do this in our on-premise environment, it would have been a pretty big challenge. And so being able to push every single commit out to production all throughout the day has been a huge win for us. And then obviously having all of our infrastructure as code in our newer environments is very beneficial. So like I showed earlier, we piecemealed this environment in as we migrated over. What we've been able to do since is now take our time to re-architect. So start to pull away all the pieces that exist in kind of more of the legacy application software and re-architect those into what we want it to be long-term. So this is always going to be a work in progress. I think someday we'll say, we've made it, we finally did it, but that's going to be a long ways down the road. But now we have that opportunity. We can actually start to pull back the layers and do things the way we think they should be done long-term. So I mentioned earlier, one of the things is kind of the speed of innovation, right? So one way that we look at that to see this, and I'll just show a really quick clip here. And so I mentioned continuous delivery, so going to production with every single commit. I also mentioned some of the stuff with infrastructure as code. So this here is just an interesting way that we've taken to just visualize what goes on in our environment throughout just a few days here. So these are commits. Each one of these go into production. So every time somebody's committing here, these are going straight to production immediately. And this includes things, even including infrastructure. And so you can see some crazy things happen. People make mistakes. That's what that shows. But this is what it's really enabled, the speed of innovation. So this is just over a short period of time that we're having this much work happen and actually go to production. So the key points to wrap up. So plan and rehearse, extremely important. That led to a successful cutover for us. Leveraging the quick wins is extremely important. So things such as Elastic Load Balancer. So don't go try to run your F5 load balancer out in the cloud. Just try to cut over to Elastic Load Balancer. It's just one simple example. DNS is another one. So once lift and shifted, plan to re-architect. Don't think you're just good enough once you get there. You don't want to be like the picture I had earlier. And then really embracing the patterns such as infrastructure as code, as well as continuous delivery or deployment. Those are things that, at least in our case, and I think in most people's case, if done right, you can go extremely fast while maintaining control. So with that, if you want to learn more, we have a booth downstairs. There's a session tomorrow afternoon that actually I think is much better than mine, and I highly, highly recommend. So the session tomorrow afternoon is actually about a global scale image processing pipeline. So processing satellite imagery on a daily basis around the globe. And it uses some crazy technology, so using Amazon ECS heavily, using the GPU instances on AWS as well to do deep learning on top of the imagery. It's actually really crazy. So I highly recommend it. And lastly, we're hiring, so of course, if you're interested, come talk. But with that, I can open up for questions or come up and talk to me after we're done. No, we were not. So that was not really something we could do until after we got out to AWS. Various reasons. So the whole pipeline to actually deploy would have been extremely slow. The other reason is we started to re-architect towards microservices as we moved out to AWS. And so that allowed us to have much smaller deployments than what we had on premise. So yeah, there's certainly changes to the testing strategy. We've been through many iterations of the product at this point. So we're on, we call it 2.0. I would say it's actually probably more like 4 or 5. But in that period, we did certainly change our testing strategies. Questions? To a degree. There were certain things there that presented interesting challenges to actually just leveraging something like CloudFormation or Terraform. And so some of it is actually written more so, I wouldn't say in like a native infrastructure as code solution. It's more so written in like Modo or something like that. And so actually just an SDK instead of something like CloudFormation or Terraform. So yeah, so we didn't get to the point where we would have liked with it, but everything since then has been. Yeah, we're in the middle of that migration as we speak. So yes, so it's in progress, and the plan is to move towards Terraform with almost all of it. So. Yes, Zach. That's a good question. So we actually, prior to moving, we were split between SVN and TFS, and we actually had some stuff in GitHub as well. So things that were in GitHub moving to GitLab, I don't think we saw much of a benefit necessarily other than some of the security implications. For things that were in TFS as well as SVN, there was a few general things I would say that were big wins, like some of the workflow, like TFS now you can do that. When we were using it early days, some of the workflow that we had desired wasn't quite there. So that was a major win. Things such as merge requests and actually having approvers and things like that. So. Other questions? All right. I think we're at our time, or very close to our time. So if you have any other questions, feel free to stop up or hit me up if you see me walking around. So thank you, everybody.